What's another name for ions? Our electrolyte. And I pulled up Chapter 9. Okay. Something told me to download 9 and 10. Well, I said, well, no, I need Chapter 10. And Chapter 10 is on me. All right, let's see if we can get it this time. So, in looking at our muscular system, all right, with Chapter 10, what we're going to see is what is termed our gross muscular system. This is going to match up to the list that you're given in the syllabus. When we look at the muscular system, we need our muscular system for the ability of movement. Now, that applies to any of it. That applies to the cardiac, the skeletal, and the smooth muscle. We need our muscle for stability. We need it for the control of body opening. We need it for our generation of that 98.6 body temperature. We're going to see that it's going to also help with glycemic control. Now, glycemic. Sugar. All right? We're going to have to think about that one for a second. How is it that the muscle, let's just think about the skeletal muscle as a whole, could have anything to do with sugar control in the body? Making ATP. Skeletal muscle and cardiac muscle are going to require huge amounts of ATP. Now, when we look at the skeletal muscle, there are some terms that you're going to need to become familiar with. And you'll notice that this is also on your study guide. When we talk about muscle, muscle is said to have an origin, an insertion, a belly. We call the origin the head. Every muscle of the body has an origin and an insertion. And that origin and insertion are going to be, they're going to affect how that part of the body moves. When I look at muscle, muscle that I usually like to show. But when we look like this, you guys know this is the posterior portion of the leg, right? Okay. So we'll have an origin, we'll have an insertion, and the portion that's in between, that's the belly. All right. It's almost like you have thinner parts and a thicker part in the middle. We're going to see that we have tendons. We've talked about ligament, okay? Tendons. This is what attaches muscle to bone. And a huge one is this patellar tendon, okay? That runs across the knee, for example, where we've got a quad running into the tendon. When we talk about, for example, in the abdominal area, where we have a very broad, or broad tendons, I should say, throughout this trunk portion of the body, those will be termed an aponeurosis. All right? You'll see that term. When we talk about movement of the muscle, muscles, when movement occurs, it always occurs because of muscle working in groups. Okay? Just a simple movement of your arm, like this. Okay? A flexion and an extension of your arm requires certain muscles of the arm to work together. When they work together, we'll have a muscle or muscles that will be considered an agonist, an antagonist, and a synergist. It makes me think about my literature class, okay? And in literature, when like a Shakespearean play, okay, you always have like a antagonist, okay? They have different names, okay? Like the lead actor, our prime mover, okay? We have fixators. These would be the cast of the play, okay? And an antagonist, the other person who's like causing trouble, all right? And so it's very similar with the muscle. The agonist, okay, the muscle that when it actually contracts causes an action. When a muscle contracts, movement occurs. Whether I'm talking skeletal or smooth or cardiac, okay? But in our skeletal system, the antagonist works against the agonist, the one trying to create the motion. Like they were showing in the video, the biceps and the triceps. Did y'all take note of the little highlighting that was done? Okay. The synergist, they cut, what does it mean to be, what does synergy mean? They work together. The synergists are going to be muscles that help. We'll need some that make sure the prime mover, the muscle that needs to work, is going to work. We'll need some to help stabilize the joint so that we don't hyperextend, for example. And these are terms that will be used with the movement of the muscle. A good example is going to be the biceps and the triceps. Now, let me stop right here and make a little note. Biceps. How many? Two, because it's bi, but does it only exist in the upper arm? It's also in the leg. So you can't simply just tell me biceps. You need to identify, am I talking about the biceps brachii, or am I talking about the biceps femoris? Okay, so you need to make sure that you always, because some things, because biceps, simply telling me something about the structure. Okay, bi meaning two. So we're looking at how we could have an origin, we could have an insertion, we've got a belly movement that can occur, flexion, extension. They're trying to show how with this structure of the biceps and the triceps, if one begins to contract, the other one relaxes and the movement in a certain direction. Okay? So we would have our prime movers, we would have our fixators, we would have our synergists, we would have the agonist, the antagonist. In your syllabus, I have a list of the ones I want you to know. And I've already determined origin, insertion, and action. It's all color-coded for you. You do not need to know that information for this week's test. That is the information you need to know for the practical. Okay? So don't spend time studying that for the test. Another way that we go about identifying muscle or naming muscle. Muscle has very distinct shapes. Muscle can be circular, which are the ones that control the openings of the body. We have what's called convergent. They have a triangular shape, such as the pec major and the pec minor. We have the ones that are parallel. Now, what are they talking about? What exactly is running parallel? My muscle fiber. Now, do you guys remember when we were talking about cells and I said that the muscle fiber is the same thing as a muscle cell? Okay? This is what I'm talking about. If you look at the shape, okay, for example, trapezius, my fibers are running a certain direction. That means these are my muscle cells. These are fibers running in a particular direction. They are cells. That's a type. That's a concept I'm going to really need you guys to understand. That a muscle fiber, which could be this long, is one cell. Okay? So try to kind of keep that in mind. So we can name them after their shapes. They can be named, they can have something in their name, identifying which direction. They are parallel. One that almost looks like a feather, pinnate. If it's two of them, they might have the term bipinnate in their name. Multi-pinnate, which is the deltoid. Okay? Fusiform, where it looks like they definitely have a really nice flowing shape of the fat belly. Okay? So, when we talk about our naming of muscles, when we look at the naming of muscles, sternocleidomastoid, that's a muscle. Where is it?
Sternum.
Okay.
Probably right.
All right. Sternum, clavicle, mastoid. Sternocleidomastoid. One of my favorites. Okay. Say that 10 times really fast. All right. The nomenclature. I am being told what the origin is, what the insertion is. I can be told in the naming of a muscle, biceps femoris, for example, I can be told the location of a muscle, for example, pectoralis, gluteus, brachial. That's letting me know what area of the body it can be found. I can be told the size. The pectoralis major, the pectoralis minor, okay, adductor longus, okay. I can be told what the size of it is. I can be told the shape. My teres major, teres minor, okay. I can be told my orientation, rectus abdominis, okay, letting me know the type of parallel there is. I can be told the origin and the insertion. One of my favorites, sternocleidomastoid. I can be told the heads that are present. Biceps, triceps, quadriceps, okay? I can be told the function. Is it an ad or an ab? Masseter, cheek, okay? The naming of muscles It's usually going